And so there comes a point in the time of all electrical equipment that something has to be done. Either you are going to extend the life of the equipment, you're going to just cut bait and run and replace the equipment, and maybe there are other options. That's what we're going to be talking about today, and our focus is going to be on motors. So let's talk motors, let's talk replacements and everything that goes with that as much as we can in an hour, and it all starts now. All right, welcome back. We are going to dig into some cool stuff. We're going to talk about motors. We're going to talk about replacements. We're going to talk about all the different options. We'll go through as much as we can in an hour. But first thing I want to talk about is we got some industry news. We got some cool industry news. The National Electrical Code, the 2023 version of the National Electrical Code, is available online right now as we speak. You can take a hop out to the web, go up to, hey Nihad, good to see you again. And you're back in North America. That's cool. So NFPA 70 is out 2023. Michael, the 2023 code is available on the website from NFPA. And if you have NFPA link, you have access to the 2023. Look at this. 2023 NEC is available on NFPA link, and you can come here and go to free access. You click on free access, you select the edition of the code that you're looking for. There's the 2023, and you can say view and view the latest edition of, you got to hit agree, but you can view the latest edition of NFPA 70. So hopefully you find that of interest, and you're going to go out there, get your copy of NFPA link, get out there and take a look at what the latest edition. Now, let me just tell you, if you go to this free access location, what you will see is the first printing of that document. Whether it be the 2023 code or the 2020 code, whichever edition you select, it's the first printing. It doesn't include the TIAs that were adopted, doesn't include any erratas and things of that nature. When you sign into NFPA link online, you will have the latest version. When a TIA is adopted, a tentative interim amendment, whatever that T stands for, it will be incorporated when it goes through its process and it's approved. It gets folded in to the latest version. But again, you're not going to see that if you go to the free access. I just be mindful of that. We got Felix Sandoval in the house. Thanks for joining us in, Steve. Looking forward on Article 430. Amen, brother. And we're going to talk NFPA 70B as well. So I just want to let everybody know the latest version of the National Electrical Code is out there. You can view it online. I know the books are probably, I don't know. I think Jeff Sargent prints them himself in his garage, but that's okay. But they're working on that as well, and they're going to get us. They'll get that all out to us. The TSDN people, absolutely, Felix. You're going to show your age, brother. So replacing. Now I'm going to focus on. I mean, the whole discussion around motors. It's a pretty generic discussion if you think about it. And in fact, when you think about motors and generators, in some cases, they'll reference them as machines. In fact, we're going to see that in 70B. But in many cases, they will reference that in as a machine. And if you think about what's going on from a motor and a generator, you've got very similar components. You've got movement, right? You're going to have a rotor that's moving, stator that's stationary. In the case of a motor, you're driving a load. So when we think about replacements, when we think about the condition, Mr. Bellantoni in the house, when you think about condition of equipment and whether or not you're going to, seek replacing, reconditioning, all this other good stuff, we'll talk about rewinding, all that crap. You've got to think about the load you're driving. Don't forget about the big picture. You got to think about what mechanical load am I driving, and then also what's behind us protecting the motor. You've got overload elements, you've got overcurrent protective devices, you might have a variable frequency drive in there, you might have different types of starting technologies, cross the line, variable frequency, adjustable frequency, voltage. There's different technologies, and you can't forget about the big picture. Yeah, we're going to talk motors, but what I want to make sure is that you understand the thought process is much more than just that motor. All right, so let's do this. Let me show you something. All right, motors. So we're going to talk motor replacements, and the first step is, how do you know that it's time to replace a motor? I mean, that's a big call, because, Mr. Bellantoni and Felix and crew, motors can be quite expensive. I mean, you're not talking. I'm not talking about what we could be talking. We could be talking about the motor that's on your refrigerator or your HVAC unit, or the motor that is. You're not going to replace a ceiling fan motor, right? Motors, though, at some point, you're going to know that they've reached an end of life. And there's maintenance you can do to help extend that life. And you got to think about performing maintenance on your equipment, not just a motor, but your equipment in general. And that's what NFPA 70B is all about. And I do want to talk about 70B as well. We'll talk about the structure of 70B and maintenance, because what you want to try to do is avoid that when it's time to replace a motor, because it can be expensive. So what are some of the things that we look at? And these aren't, and by no means is this an exhaustive research in motor replacements, motor maintenance, all that jazz. What I'm hoping to do with this 1 hour window is stimulate your senses, stimulate your thought process. If you're thinking about a motor, if you're going to be thinking about it in the future, if you're a design engineer, if you're an electrical inspector, if you are a contractor, I want to just at least plant some seeds so that you understand the thought process. And again, by no means is this is not your go-to resource on everything you need to know about motors. So if you see, remember, a motor is driving a load. And you've got to think about that connection point. There are bearings inside of that motor. There's a coupling, right? From the shaft of the motor to whatever it is you're driving, whether it be a pump, a fan, a blower, vacuum, whatever it is, conveyor belt, whatever that equipment is that the motor is driving, there's a coupling. And if there's an alignment issue, and it may be fine when you first install it, but over time, due to a lot of different things, if that motor is mounted on, say, a conveyor belt that's constantly shaking, and you're throwing material onto the belt and you're moving your equipment, things can get out of an alignment. And when you have a misalignment, you can put torque and different types of pressures on the shaft that it's not intended to have, and that may wear bearings out. And that may make your motor work harder, right? And then you get into the whole concept of consistent overheating. Maybe your overloads are tripping the motor out. Maybe, if you are lucky and you are monitoring the energy usage. Now, a lot of facilities will have energy management systems, and you know, they'll put a power distribution system together. They'll put meters. Typically, what do we use an energy management system for, Joe? We use an energy management system for things like energy billing, right? You want to save money on your energy bill, so what do? You at the least that you can do is monitor your energy usage at your main, and then that will give you an idea and a concept of your demand profiles, right? Because in some facilities you'll get a demand charge, but a meter up at the main is probably not going to help you ascertain or determine the energy usage of a motor somewhere downstream. So as you put monitoring equipment further down into the distribution system, you get more granularity and data. And if you have an energy meter that is on the branch circuit feeding the motor, and in some cases, the relays and the protective devices, depending upon the price of the motor. So the more expensive a motor gets, the more equipment you'll probably have on that motor to give you data. That data can help you save money, right? Because motors, when they're running, will use energy. And if you understand when they're running, you might be able to shift some loads around, turn this pump on, or turn that blower on, not when that blower's on, or not when this process is going, to avoid peak demands and things like that from an energy bill perspective. But you can also do some trending of the energy usage of a specific motor that will give you an indication if it's using more energy on average overall. There can be a lot of different things that are going on. It may not even be related to the motor itself. It might be related to what it is you're turning, right? It could be the conveyor belt. It could be the bearings on the conveyor belt, and you don't need to maintain the motor. You need to maintain the equipment that you're driving. You got to think big picture, in my opinion. You got to think big picture before you decide to go out and replace something. You need to figure out the overall, what is the motor doing? What is it driving? If I am going into a consistent overload, or meaning I'm heating the windings of that motor, why is that happening? You can perform maintenance on that equipment that you're driving, and that will extend the life of the existing equipment, that motor that you have. But again, I mean, in some cases you may say, look, the amount of money I'm going to spend to monitor that motor, the motor, if I need to replace it, I'm going to go out and buy a new one because it's cheaper than, or less expensive than the investment to do all the monitoring to try to extend its life a few extra years, right? So you can do that cost justification. But these are some of the parameters that you'll use to determine whether or not you have to replace the motor. Now, before I get into some of the other parameters, let's talk a little bit, since we're talking about life extension, right, and trying to avoid that replacement. Let's just talk about NFPA 70B. Now, NFPA 70B. I'm going to bring up NFPA. No, I'm not going to bring up NFPA link on 70B, and the reason is because NFPA 70B is going through a transformation. It's moving to a standard. So I'm going to grab we've gone through the public comment phase. I'm going to grab the second draft results, which you can grab out there on NFPA. Go to www.nfpa.com/70B next. 70B as in Bob, NEXT, and go to the second draft meeting. Go back, I think I grabbed the wrong one. Oh no, second committee ballot stage. So you'll view the public comments. Click on view public comments. That'll show you where 70B stands. Now, I did just give you an overall. Chapters 1 through 9. Chapters 1 through 9 are your general requirements. Chapter 9 is where you're going to find this table, and you'll notice what they call motors and generators, rotating equipment. And I'm just going to make sure they throw generators in there too. So it's chapter rotating equipment, and then there's motor control equipment, but rotating equipment is chapter 27. And it says the chapter identifies electrical maintenance requirements for rotating equipment, machines. That's what they call motors and generators, machines, and their ancillary devices. So they take a general approach to machines. I'm just looking. They got machines, they got motors, surge protectant, there's motor starters, and I'm not seeing anything in here that specifically calls out generators, substations and switchgear, power distribution transformers. So I would throw even the generators into the machines because they're not very clear as to whether or not it's just motors, but I would throw generators in that machine discussion as well. All right, so this is where you'll find in chapter 9, they give you the maintenance frequency. So it's field testing and, maintenance intervals. And there's a table in there, and the large table, and I'll tell you the table number, is table number 9. It's chapter 9, 922, maintenance intervals. The first line is infrared thermography for all equipment. Yes, you can use infrared thermography on motors, and that can tell you where heat's generated. It can tell you if there's heat in the bearings. It can tell you if there's, even on the connected equipment. Don't forget about the connected equipment. You might not have to replace the motor. You might have to replace the equipment that you're driving. Got to get out of the box, okay? So in any case, maintenance intervals, they have the general, all equipment, infrared thermography. They'll tell you condition 1, 2, and 3. So let's talk about condition. Do I have a slide on condition? Thought I did, but I do not. Okay, let's talk about condition though. There's 3 different conditions, and I'll tell you what they do. They have physical conditions. So physical condition 1, 2, and 3. In physical condition 1, you're looking at new equipment, right? So the equipment appears like new. It's the enclosure, the outside, all that good stuff is clean. It's there's no moisture intrusion, and they say and tight. So all your bolts and everything are tight. No unaddressed notifications in the continuous monitoring system. So if you are monitoring that, and I don't know what I would throw into the continuous monitoring system. If you could throw if you have a variable frequency drive, if you have, I would almost say your motor starter with your overloads. If the device has tripped an overload or tripped your motor circuit protector, things of that nature, if nothing has been addressed, there are no active recommendations for predictive techniques, and previous maintenance has been performed in accordance with the electrical maintenance program. So that's condition 1. So everything is going fine. You just have you got your new vehicle in the garage and everything's looking good. You're going to be doing infrared thermography every 12 months. You're going to be doing visual and cleaning and lubrication and mechanical servicing and electrical testing every 60 months, 5 years. Condition 2, that's vision. Now let's take a look at condition 2. Here they're talking that your maintenance intervals deviated from past results, indicated more frequent maintenance in accordance with manufacturer's data. So if your previous maintenance reports indicate that something needs attention, say, for example, let's say cleaning, and you realize this motor is in an area where dust accumulates a lot on the outside of that enclosure. The fan guards and whatnot have dust, and it needs to be cleaned more often than what this is saying. The results of your previous maintenance may drive you to a condition 2 and say, instead of 60, you're going to go to 36 months. If there's been notifications from the continuous monitoring system, and there are active recommendations from the predictive techniques. So if you have predictive technologies on there, for example, your you are monitoring the energy usage of a motor. I mean, we're not going to do it on a small motor. We already had that discussion. But let's say you're monitoring that energy usage and you're watching the energy usage go up, but nothing else has changed. There's no explanation for it. You know that motor is working harder than it did, 6 months ago, or when you first put it in. Maybe it's 5 years ago. Whatever that time interval is, all of a sudden it's starting to work harder. Something is going wrong. You're going to need to pull maintenance on it more frequently. You're into a condition 2. All right. So, and then there's physical condition 3. If you have changes in operation are noted, where any of the following criteria: the equipment has missed the last 2 successive maintenance cycles in accordance with the maintenance program. So you haven't looked at this motor. I think this is the last 2 inspections. So that means if you're doing it every 60 months, that's 120 months. You haven't looked at it in 10 years, right? So now you're into a physical condition 3. The previous 2 maintenance cycles have revealed issues requiring the repair or replacement of major equipment components. Repair or replacement, that's what we're going to be talking about. And I want to talk about that word repair. We'll talk about that word repair. There is an active or unaddressed notification from the continuous monitoring system, and there are urgent actions. So you have 3 conditions for the equipment. Now, what do we do when we do a visual inspection? You're going to be looking at the application, overall application. Can't stress that enough. You're going to look at the physical condition of the motor. You're going to look at any indicating device statuses, labeling, the grounding and bonding of the equipment, the machinery alignment, right? So you have a motor or a generator. I mean, if it's a generator, something is turning the rotor. If it's a motor, the rotor is turning something. You need to be thinking about that connection point. Grounding and bonding, machinery alignment. That's your visual inspection. Now you got your cleaning. You've got to clean the surfaces, the enclosures, the insulating materials. And you want to keep it clean to prevent that buildup of contamination, because contamination can negatively affect the performance, reduce the life expectancy. So if you're trying to determine whether or not you need to replace that motor, and these types of characteristics are going to help you, you might realize that, look, it's in a harsh environment. I'm not pulling proper maintenance. It's overheating. Go back to that other list. I got heating. I've got my overload elements are taking it out. Maybe I've had a short circuit every now and then. I don't know. You've got something going on with that motor, and it's not because of the load. It might be because of the lack of cleaning, because of the environment that it's in. So you've got to think about that. Lubrication. You got to lubricate the bearings, the couplings, auxiliary devices. Remember, it's driving something, and if you don't lubricate the equipment that the motor is driving, that's going to make your motor work harder, and it could reduce the life of the motor. So you're going to maintain and lubricate all of those systems. This is 70B's telling you to do this stuff. Mechanical servicing. You're looking at the integrity of the accessible bolted connections. The cooling system operation. The machine guards and assemblies, all of that makes a difference. How many times have you seen those machine guards really damaged and whatnot, right? So now we get into the electrical testing. What are we testing with regard to looking at the condition of a motor and from a maintenance perspective? Remember, this is every 60 months in condition 1. And if you looked at rotating equipment in the tables, what the tables back in chapter 27 tell you for motors is what you can do when the motor is energized and what you need to do when the motor is, it's like a standard online test. There's a standard offline test. Then there's the enhanced tests. And those are like, for example, some of these tests, so I'm going to go down through, there's like 20 some tests. I'm just going to run down through them. You can always pause this and look at it later. But some of these tests are standard online tests, and some of them are standard offline tests. Some of these are what they call enhanced tests, whether they be online or offline. And the reason you would do an enhanced test is when you didn't quite get the results that you thought that you wanted on the standard tests. So those are important aspects that you need to think about. And maybe those are the reasons why you might want to start considering, I might be on that journey to replacement. I'm not getting the bolted connection resistance tests don't look good. The stator armature winding tests don't look good. The wound rotor field windings, the stator armature winding polarization. You've got stator winding DC dielectric withstand. You've got the field winding withstand tests. These are some of the tests, the electrical tests that 70B tells you to be performing at various frequencies, some online, some offline, some standard, some enhanced. Machine space heaters, vibration analysis, current signature analysis, partial discharge. So all of these different types of things are important to help us understand what's going on with the motor itself. All right, so at some point, you're going to have to make that determination on whether or not you have to replace or do something with that motor. Now, the next thing you need to think about, and I'm going to make an assumption here that you have an existing motor, right? So I'm not talking about a brand new motor installation. You have an existing motor. I'm telling you that the nameplate information is very important for you to get your arms wrapped around. So in fact, what you might want to do is take a picture of the nameplates. When you're installing these motors and you start building that file for the motors. Now again, it's, I would say not all motors are treated the same. Some are much more expensive than others, right? So you're not going to be looking at every little blower motor that you have out there. You're going to be looking at your larger motors that are expensive. You're going to want to take a look at that nameplate information when you're building on your maintenance plans and have that information ready so that if you determine you need to replace that motor, you'll have all of the parameters that you need. You got to think about the power, efficiency, and torque of the existing motor that's in place. The application, what's it driving, right? That'll tell you sort of the type of motor that you're going to need. You need to think about the frame size. Now, what does the frame size get you? The frame size, let me see if I can do this. So, so you got horsepower. That's your power. Your horsepower, obviously, if you've got a 1 horsepower motor, you don't want to put a 3/4 horsepower motor in, right? Now the other question is, well, you say maybe I want to put a larger horsepower motor in. Okay, you can do that. And one of the reasons you might say you want to put a larger horsepower motor in is because in certain periods of times you drive that motor beyond its horsepower rating because it's working harder. So that's an important thing to consider. But increasing the overall horsepower of a motor might not be a good thing because now you're working it much less. You're less efficient. If you're not working that motor at its horsepower rating, at its speeds and all of that good stuff, torque and all that good stuff, you're working probably at less efficient from a motor perspective. So one of the things you got to think about is possibly using a service factor. Now, the next question out of your mind is, what the heck is a service factor? Now, when you think about a service factor, you got to think about that's a motor that is rated to be able to do a little bit more work for short periods of time, not continuously. Because in some cases, like say you have a pump, right? And remember, motors, you got to think about what you're driving. If that motor is driving a pump, and maybe for a short period of time, while that pump is I don't know, moving whatever it is that it's moving, whatever fluid, sludge, water, whatever. Maybe for a short period of time, that motor's going to work really hard, but then it doesn't have to work as hard. So that short period of time, you might need a service factor on that motor so that you can get it to not overheat and be built to handle the short duration equipment loads. So that's all in your, that's all, like when you think about the amount of power and whatnot that you can put out with that motor. You got to think about, so that's the horsepower, right? Also got to think about the type of motor. So is it a single phase, 3-phase, right? Is it capacitor start? What all the different types of just motors in general? You want to match the same type of motor that you have in place. How fast, the RPMs, what's the rotations per minute that you need out of that motor for the application. The NEMA design. Now the NEMA design is going to get you into, let me find that. Hold on. The NEMA design. Let's talk about that here in a second. View. How do I go window? Nope, I don't even have it open. Do file, open recent, and let's talk how motors work. I think I might have the, no, not there. File, open recent, motor protection. I gotta find my NEMA start. There we go. All right, so let's talk about that. All right, if I go to slideshow, play from current slide. All right, here we go. All right. Now, first things first, you're going to take a look at the motor nameplate, find out what is the NEMA code that it is, right? And what that tells you is your speed torque curves. You'll have what we call the starting torque, you'll have your pull-up torque, you'll have your breakdown torque, your full load torque, and all that jazz. And if you're trying to determine from a replacement motor perspective, if you can't get the exact same one, but you know it's a specific type, a NEMA design, say a NEMA B, or etc., then you're going to know the speed versus torque curves, and then you can compare that with whatever it is that you're driving. Hopefully, you'll know what motor is there, and you can find the same NEMA type of motor so that you know the general torque curve that you're going to have. NEMA B is like one of the most prevalent. This is an example of the motor is on the left, I guess, yeah, left. And then the load is on the right. So what you would do is you would typically compare to make sure that you can get that motor starting. For example, let's take a look at this one. You have a constant torque load, that straight line at 175. This motor, which the starting torque is at 150, won't be able to turn the constant torque load, right? So this is how you sort of compare your speed torque curve with your load curves. And you have to understand what load it is that you're driving. Say it's a conveyor belt and you've got that conveyor belt full, right? The torque that it takes to get that conveyor belt moving has to be less than your starting torque on your motor, for obvious reasons. You're going to get that conveyor belt moving, and it might take a longer time to get that conveyor belt up to speed to where your motor is going to work differently. So you've got to understand the different types of NEMA designs, and these are the different torque curves. You got a NEMA design A, B, C, and D. There is an E as well, but I don't have the diagram for that one. And you'll notice like a NEMA type D, which is that has a very high starting torque and this just narrows down, does that. I gotta do it with my left hand. That will help you understand the motor when you're thinking about replacements. You got to make sure you match that NEMA design, because if you don't, then you might not be able to start that load. And your locked rotor amps may hang in there longer than what your overcurrent protective devices require, which will show you some of those curves as well. So motors, NEMA A and B, motors have a higher starting current. They're high efficiency, commonly used for fans, pumps, blowers, motors, but don't go by the commonly. Look at the nameplate. I might even have a nameplate in here. I do. So here's an actual nameplate. I believe it's a Boulder motor. When you have a 100 horsepower motor, they tell you the volts, they tell you the amps at the different voltages, the RPMs, 1185. You have a frame, what the frame tells you. So the frame is going to give you the physical mounting structure. So when you're replacing a motor, you're going to go buy a new one and put it in place. This is beyond NEC and all this other jazz. You need to be able to make sure that you can mount it in place with the bolt holes and whatnot, and your shaft is going to be lined up correctly with whatever it is that you're driving. If you don't have the proper shaft alignment, if you don't have the proper bolt holes and whatnot for mounting, then you're looking at replacing a little bit more than just the motor, right? There's a service factor, 1.15. Again, that's for when that motor is working harder for a short period of times, not continuously, okay? And that just tells you that the insulation and all that good stuff is built for is built up for those short duration work that it's doing. There's your design class B, your class B. So this is a B motor. So based upon the B motor, you know the motor torque speed curves, right? The other thing that you're going to be thinking about, that you have to think about, is your locked rotor amps, your start time, and your full load amps. Now, when you think about Article 430, the overload elements, the sizing of the conductors, you're going to be using the tables in the National Electrical Code. Because those numbers are generic in nature. The short circuit protection and all that jazz is going to be driven off of, especially your inrush, is going to be driven off the motor, specific motor that you're using. And that's important to know when you're doing the replacements. Why? Because when you think about the protection, you just throw a curve up there. When you think about the protection, boy, there it is. So when you think about the short circuit protection, that knee of where that motor transitions from lock rotor amps over to full load amps, whether it hangs in there longer or shorter. If it hangs in there longer, you could open your overcurrent protective device. You could open, even if you have a that's a motor circuit protector, but what do we use whenever we have a motor circuit protector? In the picture, we use an overload element, right? Which I have a picture of that. Here it is here. No, that's a fuse and an overload element. Here's your motor circuit protector and an overload element. You'll notice the overload element is that line that that goes like this. Wait, nope. It goes like this, right? If the locked rotor amps hangs in there longer, why would the locked rotor amps hang in there longer? Felix, is because my conveyor belt's not coming up to speed. My pump is not coming up to speed. I didn't pick the wrong NEMA design, and I'm having it work harder for a longer period of time to get things up to speed. I don't have the right horsepower rating. There's a lot of different reasons why you might have that motor hang in there longer before it transitions to full load amps. That's why it's really important to cross your T's and dot your I's before you do that replacement. But remember, the code tells us that overload element we're picking on based on a generic, the table. The short circuit protection I'm picking off based upon the motor that I have in, that I purchased, the nameplate information. These are just different examples of the level of protections that I would, all the different methods. And I got to think about all of that whenever I am selecting your your overload elements and your short circuit protection and all that good stuff. Right? There's your maximum circuit protection size. You got to think about your short circuit and your ground fault. It's based on the full load amps found in the tables. We do not use the motor nameplate when we're talking. Actually, yeah, it's the short circuit protection. We don't think about I had it backwards. We don't think about the nameplate information when we're doing our short circuit and ground fault protection. The overloads, you will base it upon the nameplate. So just had that backwards. There's your table 430.52, your polyphase motor. There's your non-time delay. So you're going to pick this. This is your short circuit protection based upon the tables. Your overload elements is going to be driven off of the nameplate for your overloads and whatnot. Steve, the motor might be starting while under load and the locked rotor currents could last longer. That's exactly right, Steve. So when your motor is starting while it's under load, that line, this line right here, that line right there that goes up and down, that's your locked rotor amps. And it may take a specific amount of time to transition to your full load amps. And that's when your load has gotten up to speed and now your motor's not working as hard. That transition point is critical because you can open your fuse, you can trip your circuit breakers, and if you have a very expensive piece of equipment, you might actually be into relays, right? So you might be getting into much more complex devices, like a motor relay that has the ability. I know some of the older relays. I don't know if I have a good curve of it. Some of the older relays, I know we had, there was one manufacturer who had a product that basically you could establish a point right here on this curve so that if the locked rotor amps took a little bit longer to transition, you opened. Because here's the thing. What you want to do, Steve, is you want to remove power from the motor as quickly as you can to save the life of the motor. Now, here's the challenge. That relay that has the parameters set for that starting curve, for that motor, when you go through the replacement, it's not just a swap it out and turn it on. You're going to have to look at what is the start curve for the new motor when you put it in and compare that with the overcurrent protection, especially when you get into relays, because all of these different settings could prevent you from starting the motor. And what you don't want to happen is you don't want maintenance personnel out there replace the motor, have it trip the device, and start fiddling with the set points. We call that ungood, right? So you want to make sure, especially the larger, you're going to have RTDs, temperature sensors in there. You could have temperature sensors in your motor that would trip the motor protective device that says, hey, the temperature in the windings is higher than what it should be, and takes it offline. And then you have to investigate why. But if your new motor has temperature sensors and your old motor didn't, right? So here's another thing you need to think about. If your new motor has these additional features, like say temperature sensors, and the relay that you're using doesn't have the ability to monitor those temperature sensors, then you need to think about buying a new protective device for that motor. And replacing the motor with something new could cause you to have to replace the relay or the protective devices upstream. It may drive you to possibly replace all of your mechanisms that connect all those things together. So those are all important pieces of the puzzle that you need to think about. All right, so let's continue that discussion. All right. Okay, so we talked about the NEMA design. That's an important. The frame is important. Again, the frame is going to be important for when it gives you the dimensions for the motor, the shaft diameter, the shaft height. So if the frame numbers of two different motors are identical, the mounting dimensions and shaft diameter will be the same, even if the motors are made by different manufacturers. That's an important thing to remember. A great reference for you is NEMA. So if you go to, what's the link? If you just search NEMA motors, I'm just going to do a Google search or whatever your browser, whatever your search engine favorite is. NEMA motor and generator. So I don't think there's a shortcut. NEMA.org. So just search for NEMA motors. You'll get to the general motor and generator, your machines, and great resources for you. If you can go to resources, there is activities, products, news, standards, NEMA motor generator, IS section document, application guide for AC adjustable speed drive systems, energy management guide. There's a lot of stuff when you think about motors. Gosh, oh Neds, there's a lot on high efficiency motors. Why? Because we use a lot of motors. And so you might be prompted to say, look, I'm going to buy a new motor and I want a higher efficiency motor. Well, that's going to change the starting inrush currents. That's going to change a lot of different technical parameters around that motor, and you're going to need to cross your T's and dot your I's. There is specifications for consultants, medium voltage, MG sets, motors and generators. Motors and generators, take a look at that one. I think that's MG1. Yes, it is MG1, and you can download this. Look, electronic copy is a free download. Great resource for you. Get out there and download motors and generators, NEMA MG1, ANSI NEMA MG1. Great reference for you. A lot of the materials out here on the NEMA site are free. So go out there to the standards, start peruse, and go down through. There's your NEMA motors and generators. Position papers. There's power index calculations, prioritization with a sense of proportion, reconditioning of motors. Oh, there's another. Okay, so let's talk about that. All right, so 2020 code put some requirements in around reconditioning. There was nothing in 430 that says you are not allowed to recondition a motor. The challenge with regard to the 2020 code was in Chapter 1, Article 110, for the marking. So the motor guys and gals out there, and at first I was confused because I'm like, well, I don't get it. But then I got it. I understood what their issues were. When you think about in 110.21.2, A2, equipment markings, reconditioned equipment shall be marked with the name, trademark, or other descriptive marking by which the organization responsible for reconditioning the electrical equipment can be identified, along with the date of reconditioning. It says, reconditioned equipment shall be identified as reconditioned. That's not a big deal, right? You're going to put your name on it. You're going to put your company's name on this, say, motor that's been rewound. And then it'll say the original listing mark must be removed. Now, there's what really upset the motor manufacturers. Because, why? The motors, the UL listing or the listing mark is placed on the nameplate. And if that says that the listing mark has to be removed, then you remove the original nameplate. They don't like to do that. It's okay to put the new nameplate on. You don't want to remove the existing nameplate. In some cases, they can rewind it and the nameplate doesn't change. So, but the original listing mark. So what they did in the 2023 cycle was they just said, make it, just obliterate it. Make it so that you can't read the original listing mark. And that's all they had. So they addressed the concerns of the motor guys. But here's the thing. You have to consider, when is it that you decide to recondition or rewind it? There's a cost associated with that. The motor might be so inexpensive that you just replace it. Doesn't pay. But there's probably a point where you say, look, I'm going to send this motor out to recondition it or rewind it. But remember, that doesn't happen overnight. It's not like you take it out at 5 o'clock, drop it off, pick it up at 8 o'clock in the morning the next day. That process takes time. You're going to want to walk through and understand the process. You're permitted to rewind and recondition motors. Now let's talk about repair. This whole concept of reconditioning, and we use repair in various places within the code, and in 70B we use the term repair. And I do want to touch this because the 2023 code introduced a new term, servicing. Because if you look at the definition of reconditioned tells you you're bringing it back from a non-working to a working condition. You could say, well, that's repairing it, right? So they introduced servicing, and the way they defined servicing, if I can spell it correctly, there's no E in servicing, just saying. It's not a service, there is servicing. So this is a new definition for the 2023 code cycle to help add clarity. Tell me, okay. The process of following a manufacturer's set of instructions or applicable industry standards to analyze, adjust, or perform prescribed actions upon equipment with the intention to preserve or restore the operation performance. Not restore operation. Restore the operational performance of the equipment. So, if your motor is overheating, you may be able to service the motor to get it back. For example, bearing replacements. I just, router. I bought a router, and I found that routers are hard to find these days, especially a specific brand that made a specific size. They don't make it anymore. So when I bought that router, I bought new bearings for it. And the process for replacing the bearings is documented by the manufacturer. They are known that that bearing can fail before anything else fails. And there's a process for replacing the bearings on that router. Piece of cake. I mean, not a piece of cake. I mean, it's, you got to know what you're doing. You got to follow the manufacturer's instructions very closely. Think about the torque and everything else in proper alignment, all that jazz. But there are manufacturers of information on servicing. So they're sort of, and we have to, I think we got to go through the National Electrical Code and take a look at the word repair, where we use repair, and should that be servicing? In my opinion, I believe it should, but that's something that we got to think about moving forward. But you can possibly service an existing motor to address the performance of it, get it back to where it needs to be. And it might be a part of 70B, general maintenance. That's why I brought 70B into the picture, because again, our goal has to be to try to, you don't necessarily want to just replace, especially an expensive motor. You might be able to service it. You might be able to recondition it. The moment that you say it's no longer working, I'm going to rewind it, I'm going to do X, Y, and Z to it, then it gets more extensive. Now you're into reconditioning. Now you're into putting your own nameplate on it. You're into removing the original listing mark. If you're servicing that motor, you're not replacing it. You're getting it back up into working order. You are getting it back to restoring its operational performance. You're following manufacturer's instructions. You're not having to replace the nameplate. You're not having to replace the listing mark. You're not having to put your name on it because you're following manufacturer's instructions. Signs. So what are we looking for if we're going to rewind it? What's the decision point to say, look, I need to get this thing rewound, right? You've got to be looking for signs of deterioration, same signs that you're looking for in regard to when you want to replace it, right? You're looking for burn marks, you're looking for broken parts, and any type of moisture intrusion and contaminants. Again, so rewinding, and I'm just going to give a percentage, and those of you out there who have done this before can prove me wrong. Use the chat down below, to the left, to the right, up above, wherever. You're looking at about 40% of purchasing a brand new motor is what's going to be approximately to cost you to rewind. That's like a rule of thumb that I've seen published, around 40%. Obviously, it's going to vary. So it's not, especially for very large motors, it can save you a lot of money for a very large motor. And it might be an appealing decision, but you got to think about the downtime as well. You're going to take a motor out of service, you're going to send it somewhere, you're going to spend that money. They're going to have it for a period of time to rewind it, and then they're going to get it back to you. Can you live with that from a downtime perspective? If you do your tests as part of 70B and you find that you have poor winding resistance, then you might find that you need to get it rewound. Rewinding might be a more cost-effective and environmentally safe solution, obviously. Problems with insulation resistance. A majority of winding faults cause problems in electric motor due to issues with insulation resistance. So the components that are in an electric motor affected by heat, low insulation resistance can lead to low lubrication, damaged components, and a host of other issues. So these are all the different problems that you might, ways to determine whether or not you should be, you're gonna use those to determine whether or not you need to replace it. So if you're in that mode of thinking about replacing it for those other reasons that we mentioned earlier, consider the rewinding, the cost of rewinding it, the downtime associated with it, the cost of rewinding it as well, and the cost of the downtime, right? But sometimes that might be a very viable solution. I mean, motors get rewound all the time, and especially if you have backup, right? So if you have spare motors that you can put in that place, take the one out of service, get it out, and then you don't have to worry about time. It's just get it out to the rewinding, your preferred vendor that you're using, and get that looked at. But remember, when you get it back, the code tells us you're going to have whoever did the rewinding of that is going to put their name on it. The original listing mark is going to be not removed, but it's going to be obliterated. It's going to be made so it's unrecognizable. And it doesn't say you need to have a listed motor unless you're in an application where there is a requirement that the motor be listed. And it could be a local jurisdiction. And quite frankly, a lot of this stuff is you're not pulling a permit. In most of the industrial facilities that are going to be doing this, the AHJ is your plant manager, right? That plant manager might have a rule that says, look, I'm buying listed motors, period. I want someone looking at it. My process is too valuable. My downtime is too expensive. I want third-party review. I want someone looking at this. I want to see that mark as reconditioned or refurbished when it comes into my plant. Then that's a requirement, right? They're the AHJ. They're allowed to make that. It might not even be based upon the National Electrical Code. But those options are all out there. All right. So, and again, if it's replacement, don't just think about the motor itself. Think about what's upstream, the overcurrent protective devices, the relays, the starter, if it's on a variable frequency drive. And especially if you're going to say, look, I'm going to go to a larger motor. If you're going to a larger motor, you got to think about everything, right? You're in 430. It's almost like getting a new motor. You got to think about the overcurrent, the protection, the short circuit protection, the conductor sizes, all that jazz has to be considered. If it's on a variable frequency drive, you may decide that you want to put it on a variable frequency drive. You may get the exact same motor, and for efficiency reasons, reasons to say, you may not want to get a specific, you may not want to increase the horsepower or whatever. You might want to say, look, I'm going to put it on for voltage drop. You got to think about voltage drop considerations. You got to start this motor. Okay, and if you like to put a larger motor in the place, and maybe that motor's changing function. Maybe you're going to take this motor out of service, you're going to take that conveyor belt or whatever it was driving, move it out, and you're going to put a new motor in, and you're going to be driving a different load. Now it's a new application. You have existing, you might be thinking, well, I'm not going to change any of that overcurrent protection upstream. I'm going to use the exact same equipment. And maybe it's a cross-the-line starter, and now you can't start that motor. You might have voltage drop consideration issues. You may just say, I can't start across the line, but I can do a variable voltage drive or a variable frequency drive and ramp it up to speed to address my voltage drop concerns. So there are a lot of different things you can do, but you've got to think big picture. That is, in my opinion, the key. So I've recently received a few calls asking about the overcurrent protective devices, about the drives, about whether or not the motor starters can handle the new load or the new motor that's going to be put in place. And in those discussions, you know, in one case, the existing motor that was there is no longer there. So they did not know the horsepower. They did not know any information about the original motor. They had the drive, it wasn't a variable frequency drive. It was a cross-the-line starter, but they had that. They had the load, but they didn't have the original motor. So now you're at square one. Now you're looking at the torque curves for both the motor and the load that you're driving, and then you have to determine the horsepower that you need, and some of that might be determined based upon the overcurrent. You might be able to get into the ballpark on what motor you had in there, or at least what horsepower. But you know, the NEMA design, all that good stuff is, and you can probably get the dimensions. You know, from the frame perspective, you can measure from different dimensions to figure out what frame you were in. But the challenge on the design engineers is not a simple thing. So those are a lot of different little details you need to think about. All right, so we went through a little overview of some of the things you need to think about when you're replacing a motor. I think the big takeaway from my perspective, if you just simply sit back and say, look, I need to determine whether or not I need to replace it or recondition or possibly service an existing motor. You know, don't just go straight to replacing. Think about all your options. You can replace it, you can service it, or you can recondition it. Think about all of those options before you make a move. And don't forget the bigger picture. Is the problem the motor? Is it what you're driving? Maybe, is it the protection levels? Maybe they didn't pick the right overload devices. Maybe they didn't pick the right short circuit protection. Look at the big picture before you make a decision about replacing your motors. And if you decide to go to reconditioning or rewinding, follow the rules in 110. Pick a good vendor, a reliable vendor. Address the cost concerns, the downtime concerns. You might say, I got backup motor, no big deal. Fine, you've addressed the downtime concerns. Replace the motor, take the old one out, get it rewound, get it reconditioned. So you got the replacement, recondition, you got the three options. You have maintenance. Let's talk about, think about your maintenance plan. Does that motor cost enough? Is it important enough that you should put some monitoring on it. Monitor the energy usage of that motor. So you can predict maybe you need to perform maintenance a little earlier to avoid heat buildup, to avoid damaging the motor itself, and increase the longevity of that motor. Those are all the different things you need to be thinking about. And again, the more expensive the motor, the more cost justified it would be to get as much data off of that motor as you can to avoid replacement. So hopefully you got something out of today's hour session on motor replacements. Like I said in the beginning, by no means is it an exhaustive approach, but hopefully I planted some seeds to get you thinking. Don't forget also, get out there to NFPA Link, get your membership. It's really, when you look at the cost of NFPA Link, it's like $10 a month, and it's $8 something a month if you pay for a whole year. And you don't only have access to the National Electrical Code, you've got access to 70B, 70E, and 110, 111, a host of other NFPA documents. It's worth, in my opinion, get it for a year, see how it goes. Take a look at it. And go take a look at your copy of the 2020 NEC Day, 2023 NEC today. All right, everybody. Hopefully you got something out. Again, chat it up. Steve Froming, you're testing the motor in your microwave. Excellent, Steve. Absolutely, brother. Test that motor. Test it frequently. That's what I always say. And not just on coffee, Put something of substance in there. All right. Hopefully you got something out of today's little session. I enjoyed the discussion, and chat it up. Even after the fact, put notes in there. We'll be watching it and all that jazz. All right. So thanks for spending an hour with me. Thanks for spending your lunch. If this was your lunch, your morning with me, if this is your morning or your evening, depending upon what part of the globe that you are in. So thanks for everything that you do for electrical safety. Thanks for what you do for the electrical industry. Don't forget to get your IAEI membership. Don't forget to be at these section meetings. Got the Northwest and Southwest section meeting going on right now. Get out there and participate. Thank you, Steve. Thanks, everybody. Take care, stay safe, and remember, please stay healthy. See you next week.